I want you to picture something for a second. It's a bit of a nightmare scenario,
Hmm.
but bear with me because I think we've all been there, at least metaphorically. You are standing in the middle of a massive library,
Okay.
but it's not a normal library. It's like someone has taken all the books, all the quarterly reports, medical notes, thousands of PDFs, and they've just thrown them into a tornado.
Just a swirling, chaotic vortex of paper.
Exactly. Just paper flying everywhere. And then your boss walks in, looks at this tornado and says, hey, I need a spreadsheet. I need to know every time a specific emotion was mentioned in all of these flying books, and I need it in an hour.
That is, honestly, that's panic-inducing. That is the absolute definition of the unstructured data problem.
Right, but that is basically the state of the internet and modern business data right now.
Yeah.
We're just drowning in text. We have infinite information emails, research papers, legal contracts, Slack messages, but extracting usable structured data from it.
It's a nightmare.
It's a nightmare. It's the needle in the haystack problem, but the haystack is the size of the world.
It really is. And for a long time, you only had two bad options to solve this. You either hire 100 interns to sit there and read documents manually, which is slow, expensive, and full of errors.
So error-prone.
Or you write incredibly brittle code, regular expressions to try and guess where the information is based on patterns.
And we all know how that goes. If the format changes by 1 inch or someone adds a comma.
Your code breaks. Exactly.
Right.
It's a fragility problem. But today, we are diving into a tool that claims to solve this specific headache. It's called LangExtract.
Okay.
It's a Python library hosted on GitHub under the Google organization. And looking at the numbers, it's really hitting a nerve in the developer community.
Yeah, we're talking about over 27,200 stars.
Yeah.
And 1,900 forks on GitHub. For those not deep in the open source world, that is not a weekend hobby project.
No.
That is serious enterprise interest. We are building businesses on this levels of interest.
It is. And the reason for that interest is simple. We have these incredible large language models, right? GPT-4, Gemini, Claude. They can write poetry, they can code, they can pass the bar exam. But getting them to give you reliable, structured data, rows and columns you can actually safely put into a SQL database, has been surprisingly difficult.
Right.
LangExtract is designed to bridge that exact gap.
So the mission of this deep dive is clear. We're going to explain how this tool turns that tornado of messy text into a clean, beautiful spreadsheet.
Yeah.
And crucially, how it does it without you needing to be an AI researcher or spending months training a model.
That's the key. It's about moving from just reading text to mathematically mapping it. It's a leap forward in what we call data traceability and source grounding.
Okay, let's unpack the how. Because usually when I hear extract data using AI, my brain immediately goes to fine-tuning. I assume I have to take a model, feed it 10,000 examples of what I want, pay a fortune for GPUs, and just hope it learns the pattern.
Right.
But LangExtract does something different, right?
Completely different. And honestly, it's a much smarter approach for, I'd say, 99% of use cases. It uses what we call a few-shot approach.
Few-shot, okay. That's jargon. Define that for us.
So zero-shot is when you ask the AI to do something with no examples. You just say extract the names. Fine-tuning is sending the AI to medical school for 4 years to learn everything about names.
Right.
Few-shot is in the middle. It's like hiring a really smart intern and giving them a checklist and say 3 perfect examples of previous work. You say, do exactly like this.
That's a great analogy. So with LangExtract, you aren't retraining the brain. You're just giving it a really good rubric.
Precisely. You are leveraging the intelligence the model already has and just pointing it in the right direction. The process is really just 3 steps. First, you define the prompt. This is just a text description. You write, I want to extract characters and emotions, or I want to extract medication names.
Simple enough.
Then, step 2 is the magic. You provide examples. You give the model a high-quality example to guide it. You're essentially saying, hey, computer, here is a sentence, and here's exactly how I would extract the data from it. Now you do the rest.
And step 3 is just run it.
Right. But I want to pause on the examples because the documentation uses a really specific one that helps visualize this. They use Shakespeare, Romeo and Juliet.
Which is a bold choice, by the way, because Shakespeare is not exactly structured data. It's poetic, it's messy, it's archaic.
It's full of metaphors, exactly. If it works on Shakespeare, it'll probably work on your quarterly report. So the input text is that famous line. But soft, what light through yonder window breaks, it is the east, and Juliet is the sun.
Okay, so how does LangExtract parse that? Because a keyword search for sun would just tell us there's a star involved.
Right. So LangExtract takes that poetic language and breaks it down into entities and attributes. For the first entity, it pulls out Romeo. And for the attribute, specifically the emotional state, it extracts wonder.
Which isn't even written in the text. The text doesn't say Romeo felt wonder. The AI inferred that from the context.
Correct. But then, and this is the part that really impressed me, it pulls out a second entity. Juliet is the sun. And the attribute for a relationship type is labeled as metaphor.
That is cool. It recognizes the literary device. It understands that she isn't literally a giant ball of gas 93 million miles away.
Exactly. But I know you, and I see you squinting at the documentation notes. What's the catch here?
Well, looking at the docs, there's a very strict rule mentioned. The verbatim constraint.
Yes. The discipline required. The documentation emphasizes that the extracted text must be verbatim from the source.
Verbatim. So it can't paraphrase. It can't summarize.
Ideally, no. This is to combat hallucinations. If you let the AI paraphrase, it starts to get creative. It might rewrite Juliet is the sun as Romeo thinks Juliet is bright.
Which changes the meaning, even if it's just slightly.
It does. LangExtract wants to find the exact string of text in the source.
So it's less of a creative writer and more of a strict copy editor.
Exactly. It keeps the data grounded in reality. If the text isn't there, it shouldn't be in your spreadsheet. This is crucial for things like, legal discovery or medical coding. You don't want the AI's interpretation of a contract. You want the clause itself.
That brings us perfectly to the elephant in the room with AI, hallucinations. We've all seen it. You ask ChatGPT for a quote, and it gives you something that sounds totally plausible, but was never actually said.
Oh, yeah.
In a business context, that's not just annoying, it's a liability.
It's the biggest barrier to adoption. You cannot have a legal contract parser that sort of remembers the indemnity clause. That gets you sued.
So how does LangExtract solve this? Because verbatim helps, but how do we know it's telling the truth?
It uses a concept called source grounding or provenance because the extraction is mapped to the exact location in the source text down to the characters. LangExtract knows exactly where that data came from. It's not just generating text, it's pointing to it.
And this leads to the visualization feature, which I think is actually the killer app here. Usually, data extraction gives you a JSON file.
Right, which, for the non-technical listeners, a JSON file is just a raw text file with curly braces and data. It looks like code. It's hard to read.
It's messy, and it's scary to verify. You just see rows of text. You have to blindly trust that the AI got it right.
Which makes me nervous. But LangExtract generates an interactive HTML file. You open it in your browser. On the left, you have your extracted data. On the right, you have the original document, say the full text of Romeo and Juliet.
And they are linked.
Tightly link. If you click on the data point wonder in your table, the tool immediately scrolls to and highlights the sentence, "What light through yonder window breaks," in the original text.
Oh, that is a game changer.
Yeah.
That's the difference between a black box AI and a glass box AI.
Exactly. It's all about verification. You don't have to guess if the model hallucinated. You click the data, you see the source. If it highlights the wrong sentence, you know immediately.
Right.
It turns the extraction process into something a human can actually audit.
I love that. A glass box.
Yeah,
That makes
right.
it feel so much safer to use for actual work. It changes the dynamic from trust the machine to verify the machine.
Precisely.
But speaking of actual work, let's talk about scale. Analyzing one sentence from Shakespeare is a fun demo. But what if I want to analyze the whole play? Or 1,050-page medical reports? A novel?
That's where things usually break down with standard LLM setups.
Right, because LLMs have a context window. You can't just paste War and Peace into a prompt and say, go. It's just too much information at once.
Correct. Context windows are getting bigger. Gemini can handle a massive amount of text, but they aren't infinite. And more importantly, shoving a whole book into a prompt is expensive and slow.
Whoa.
So LangExtract has an optimized strategy for this called chunking.
Chunking. It sounds unglamorous.
It is unglamorous, but it's vital. It breaks the text into manageable pieces. Think of it like tearing the book into individual chapters, but it doesn't just process them one by one because that would take forever.
It does them all at once.
It uses parallel processing. You can set a parameter called max workers. So if you set it to 20, it's effectively like having 20 interns reading different chapters of the book simultaneously.
That must be drastically faster.
Mm.
But I see a flaw in this plan. What if an important sentence starts on the bottom of page 10 and finishes on the top of page 11.
Mm-hmm.
If you rip the book in half there, you break the sentence, you lose the context.
Sharp catch. That's the classic boundary problem in chunking. If you split the data, you might split the meaning.
So how do they fix it?
They use overlap, and they use multiple passes. The documentation mentions setting extraction passes equals 3.
3 passes? That sounds like overkill.
Think of it like painting a wall. If you do 1 coat, you might miss a spot. If you do 3 coats, you're going to get full coverage.
Okay, that makes sense.
The AI reads the text, then it goes back and reads it again to see what it missed. It improves recall, which is just the data science term for did we catch everything we were supposed to catch?
That is smart. It's the Swiss cheese model stack, enough layers, and the holes get covered up.
Yeah.
But for the people listening who are thinking, wait, running a massive model 3 times on a huge data set? That sounds expensive. They have a solution for that too, right?
They do. They mention the Vertex AI Batch API.
What is that in plain English?
It's an enterprise feature. Basically, instead of demanding the answer right now, which costs a premium, you send the job to the cloud and say, get this done whenever you have free server capacity over the next 24 hours.
It's the overnight shipping versus standard shipping.
Exactly. And standard shipping is much, much cheaper. If you're processing 1 million documents, that batch API saves you a fortune. It makes the project economically viable.
Okay, so it's fast, it's accurate, and it can handle huge files.
Yeah.
But let's talk about flexibility. Because this is a Google library, right? Hosted under the Google organization on GitHub. So I assume I'm locked into the Google ecosystem. I have to use Gemini.
You would think so, but no. It is surprisingly model agnostic. Now, to be clear, the default is Gemini 2.5 Flash.
Flash implies speed.
Yes. It's the balanced option, good speed, very low cost. For 90% of tasks, it's perfect. But if you have a really complex task, maybe legal analysis, where you need deep, complex reasoning, you can switch to Gemini 2.5 Pro.
But here's where it gets really interesting to me. You aren't even locked into Google models. It supports OpenAI too.
It does. You can plug in GPT-4o. However, and this is a nuance the listeners need to catch, the documentation notes a limitation here.
Uh-oh. What's the catch?
It comes down to schema constraints.
Define schema for us first.
A schema is like a strict form. It tells the AI, you must output a date here, a number here, and a name here. Do not write a paragraph.
Got it.
Google's models support this natively in the library. They are very obedient to the form. OpenAI's implementation in LangExtract doesn't have those strict constraints hooked up yet.
So OpenAI might try to color outside the lines?
Exactly. So you have to use a flag called fence output.
True.
It's a bit of a workaround, like putting up a guardrail to make sure the data comes out clean. It works, but it's not as seamless as the native Google integration right now.
Got it. Okay, but here is the feature that I think is going to make a lot of people sit up and listen, especially in healthcare or finance.
Yeah.
What if I have data that I literally cannot upload to the cloud? Like really sensitive private data.
Right.
Medical records, legal discovery, trade secrets. If I can't send it to Google or OpenAI, am I just out of luck?
Not at all. And this is my favorite part of the library from a privacy standpoint. It integrates with Llama.
Llama is the tool for running models locally, right?
Correct. It lets you download an open source model like Gemma 2.2b or Llama 3 and run it entirely on your own laptop or your own secure on-premise server.
So let me get this straight. I could be on a plane with no internet connection or in a secure basement in a hospital, extracting data from confidential files, and not a single byte of data ever leaves my machine.
Exactly. You define the model URL as localhost and you are off to the races. It democratizes this tech for highly regulated industries that simply cannot use public cloud APIs due to, say, IPO or GDPR.
That is huge. It basically removes the privacy excuse for not using AI. It puts the power back in the hands of the person holding the data.
It really does. It allows you to build these air-gapped data pipelines.
Okay, we've talked about Shakespeare and we've talked about privacy. But let's look at a real-world scenario where the stakes are a bit higher than a teenage romance. The documentation showcases a LangExtract example. This is for radiology, right?
Yes, and this is a perfect example of the messy text problem. Radiology reports and clinical notes are notoriously unstructured. Doctors scribble things down, they dictate them, they use shorthand.
Patient took 50 milligrams of aspirin orally versus administered aspirin 50 milligrams by mouth. Same data, totally different sentence structure.
Exactly, and if you're a researcher trying to find out how many patients are on 50 milligrams of aspirin, a simple keyword search is going to fail. You'll miss half the patients. LangExtract normalizes that.
But before we get too excited, I have to be the responsible host here. There is a disclaimer in the docs, a big one.
A very big one. This does not represent a finished or approved product and should not be used for medical advice.
Right. Do not have AI diagnose your broken leg based on a report.
Please don't. But the disclaimer is about liability and clinical usage. For research and data organization, the potential is incredible. In the example, it pulls out aspirin as the medication, 50 milligrams as the dosage, and oral as the route. Suddenly, that messy text note is a database entry.
And connecting back to our glass box concept in a medical context, the visual verification is everything.
It's non-negotiable. If the database says 500 milligrams, but the note said 50 milligram, that's a dangerous error. With the HTML visualization, a human reviewer can click the number 500 milligram and instantly see the original note to verify.
It empowers the human. It doesn't replace them. It creates a workflow where the AI does the grunt work and the human does the verification.
Exactly. It bridges the gap between the chaos of human language and the rigidity of a database.
So we've covered the how, the what, and the where. As we wrap this up, I'm thinking about the listener who is sitting there with a folder full of PDFs thinking, finally.
It's a very empowering tool.
It really feels like it. My big takeaway here is the accessibility. You don't need to be a data scientist anymore to do data mining. If you know a little Python, just a few lines, really, you can build your own tool. You can be the one who turns the tornado into the spreadsheet.
You can. But if I can offer a final thought, maybe a slightly provocative one.
Oh, please do. I love a provocative thought to end on.
We talked about the prompt alignment warnings in the documentation.
Yeah.
The tool warns you if your examples aren't good.
Right. Yells at you if your examples are sloppy.
This implies something fascinating about the future of work. We talk about prompt engineering a lot. But this tool suggests that the real skill isn't writing prompts, it's example curation.
Explain that.
The quality of the output is now entirely dependent on the human's ability to provide good examples. You aren't writing code to solve the problem. You are looking at a complex text and saying to the AI, here's exactly what good looks like. Copy me.
So you're becoming a teacher.
Exactly. We are moving from coders to curators. The AI can do the heavy lifting, but it needs a human to set the standard. The better you are at explaining and showing what you want, the more powerful these tools become.
There's a profound shift.
Yeah.
It means the most valuable skill might not be Python. It might be clarity of thought.
I think that's exactly right.
Well, on that note, I think we've given everyone plenty to think about and hopefully plenty to extract.
Indeed. As the documentation says, happy extracting.
Happy extracting, everyone. We'll see you in the next deep dive.